This video is going to cover how to write the equation for the line of reflection when we're given a set of pre-image and image coordinates. So before we jump into these three examples, let's just recap some of the basic principles behind a reflection in the coordinate plane. So let's say I plot some point in the coordinate plane, let's call it point P. And we're tasked with reflecting point P over some line L. When we perform a reflection, we know that that point, as long as it's not currently on line L, needs to be on the opposite side of that line after the reflection and remain equidistant from that line as the original distance, point P to L. So let's plot point P prime roughly in this location. Again, these are just estimates for now. So the idea behind this, again, is the distance from P to L should be the same as the distance from P prime to L. And we can see that both points are on opposite sides. Now, when we measure distance from a point to a line, we're calculating the distance of the segment that runs perpendicular, or the length of the segment that runs perpendicular to that line of reflection from the point. So if I create a segment that runs perpendicular to that line, and we call the length of that line, say, D, then when I calculate the distance or the length of the segment from P prime to L, also running perpendicular, it should also be of length D. Now, when I create this image, I can see that there's a segment that connects P to P prime, and line L will serve as the perpendicular bisector to that segment. Because if each of these subsegments from P to the line and P prime to that line are the same distance, then I know the segment from P to P prime has been bisected. And knowing the fact that it got bisected, I also know that there's a special point that line L is passing through in reference or in relation to the segment P prime. That point that it's passing through is going to be the midpoint of that segment. So when it comes to writing the equation of the line L, we know that when we write the equation of any linear equation, we need a point and a slope. So the point it's going to pass through is going to be that midpoint of the segment that connects the pre-image to the image. The slope of line L is going to be the perpendicular slope to what the slope of the segment P prime is. So using those two pieces of information, calculating a midpoint and calculating perpendicular slopes, we'll have enough information to find the equation of the line of reflection. So now let's jump into these examples. Let's start with part A. We have a pre-image of triangle CDE and an image of C prime, D prime, E prime. Now, knowing the fact, again, that the line that we're trying to find is going to serve as the perpendicular bisector to a segment that connects pre-image to image points, and I know it's going to happen for all three, we only need to consider one pairing. So you can either choose C prime, D prime, or E prime. It's really up to you. For this example, let's focus in on C and C prime. So when we start part A, knowing that we ultimately need to write an equation for a line, again, we need a slope and a point that it passes through. As we've previously discussed, the point that it passes through is going to be the midpoint of the segment that connects C to C prime. So when we calculate a midpoint in the coordinate plane, we know that it's just a matter of averaging the x's and averaging the y's. So the midpoint of C prime is going to be found by adding together the x's and dividing by 2 to find its average, and then adding together the y's and dividing by 2 to get that average. And this is going to result in a coordinate of -5/2, 5/2. Now we need to find the slope of this line of reflection, and that's going to come first, or as a result of us first calculating the slope of the segment that connects the image to the pre-image. So the slope of C prime, we're just going to find the change in y over the change in x. So the rate of change between those 2 points will be -3 minus 8 for the change in the y values, and the change in the x values will be -8 minus 3. We're going to get -11 over -11, which simplifies down to 1. So remember, that is the slope of the segment. So the perpendicular slope to that segment is going to be what the slope of our line of reflection is, in which case that would be -1. So I have a point, I have a slope. we are ready to write the equation of the line, we are going to utilize point slope form. So we're going to do y minus the y coordinate equals the slope, x minus the x coordinate. And there's the equation of our line of reflection. Let's reformat this so that it is in slope intercept form. We're going to distribute the 1, or the negative 1, and then we'll add 5/2, in which case this is the equation for our line of reflection. So we have to reflect over the line y equals negative x for our triangle CDE in order to get the image points of triangle C prime, D prime, E prime. And that is the rule for part A. Let's now jump into part B, and let's choose a new pairing. So let's start with G, and we'll do G prime. So for B, we know to begin, we're going to calculate the midpoint of these two coordinates, because we know we have a segment that connects the pre-image to the image, and the line of reflection should pass through the midpoint if it's going to serve as a perpendicular bisector, which we know is going to be the result of a reflection. So to calculate the midpoint of G prime, when we average the x's, we're going to get 0 plus 2 over 2, and when we average the y's, negative 4 minus 4 over 2, we're going to get, as a result, 2 over 2, which is 1, and negative 8 over 2, which is negative 4. So the point that our line of reflection is going to pass through is 1, negative 4. So now let's move into the slope of the segment that connects G to G prime. When we do the change in y, negative 4 plus 4, over the change in x, 2 minus 0, we're going to get 0 over 2, which means the slope of our segment is 0, and therefore we have a horizontal line connecting these two. Now for the perpendicular slope, this isn't a matter of taking a negative reciprocal. We're just going to have to use our knowledge that for something to run perpendicular to a horizontal line, it must be a vertical line, and we know vertical lines have undefined slopes. So that means our line of reflection is a vertical equation, which means it's in the format x equals some number, and we know it has to pass through the point 1, negative 4. So if you can imagine, we have some vertical line that has to pass through 1, negative 4, this point. That vertical line, there's only one option, and that would be x equals 1. So that's our line of reflection. So when we write our rule, we have a reflection across the line x equals 1 for the triangle FGH in order to produce the image points of F prime, G prime, H prime. And for our last example, let's choose these last two coordinates, M and M prime, to determine our line of reflection. So we're on part C. We're going to start with the midpoint of the segment that connects the pre-image and the image point for this particular pairing. So when I average the x's, negative 5 plus 1 over 2, and I average the y's, 1 minus 5 over 2, we're going to get negative 4 over 2, which is negative 2, and then negative 4 over 2, which is negative 2. So there's the point our line of reflection is going to pass through. So now let's calculate the slope of our segment, knowing that our line of reflection is going to run perpendicular to this. So we're going to do the change in y over the change in x. We're going to get negative 6 over 6, which is negative 1. So our perpendicular slope is going to equal negative 1. Oh, sorry. Negative 1 here, and our perpendicular slope is going to be positive 1. So now that I have a point that it passes through and a slope for my line of reflection, we can write the equation using point slope form. Y minus the y coordinate equals the slope times x minus the x coordinate. We're going to convert this over into slope intercept form, in which case we're going to get y equals x after things are simplified. So our rule, we are reflecting over the line y equals x for our triangle KLM. In order to produce the image points k prime, l prime, and m prime. In reflecting over the line y equals x, that is one where we do have a set of rules that we can memorize, or we've come to discover, where we know to reflect over the line y equals x, all you have to do is swap the x and y coordinates. And when I look at this set of pre-image and image points in part C, I can see that to go from k to k prime, or l to l prime, or m to m prime, that is what happened. So I do feel confident in saying that the rule should be to reflect over the line y equals x. So there are 3 examples on how to find the line of reflection given some pre-image and image points. The steps on how to do that will be recapped here to end the video. So the first thing we were doing is we're just going to choose a pair of pre-image and image points. And then from that pairing, we're first going to calculate the midpoint. Now, once we've calculated the midpoint of our chosen pairing from step 1, we're then going to find the slope. Now, that slope of the segment we found is not going to be the slope of our line that we're ultimately trying to write, so we're going to use this ultimately. So use to find the perpendicular slope to that segment. And as a reminder, perpendicular slopes, their product, or a slope and its perpendicular slope, the product of those two values should be -1. And as long as the value isn't 0 or undefined, to determine that other value, or its perpendicular slope value, you're just going to take the negative reciprocal. So flip the ratio and change the sign, and you'll get the perpendicular slope. So now once we have the midpoint and the perpendicular slope, we're ready to go. So we can write the equation of the line of reflection. And we're going to use point slope form. Which, as a reminder, is y minus the y coordinate of the point it passes through equals the slope of the line that you're trying to find times x minus the x coordinate of the point it passes through. And once we have that point slope form, we're just going to convert over to slope intercept form, which is just a matter of a distribution of that slope and moving that y coordinate to the other side of the equation so that you get a line in the format mx plus b. And those are the steps. And after you've completed those successfully, you should have the equation for the line of reflection. And that concludes this video.